The latest research from the NanoGrav project has discovered evidence of low-frequency gravitational waves. The evidence comes from a collaboration led by Oregon State that includes researchers across 18 North American universities. Bend native Magnus Largent was one of the OSU students on the cutting edge.
Basically, what we're trying to do is use these really cool objects in space called pulsars and use them to detect nanohertz frequency gravitational waves. So these are gravitational waves with really long wavelengths. Measuring changes in their period, we're able to use that as evidence for gravitational wave detection.
Largent has spent the last few years studying pulsars, rapidly spinning remnants of massive stars, measuring these low-frequency waves.
What I was doing specifically was looking at radio signals and trying to figure out if these radio signals were possibly coming from pulsars, because the more pulsars we have available, the more sensitive our pulsar timing rate is.
The research shows that our universe behaves like a wobbling bowl of Jell-O, with gravitational waves causing ripples and vibrations. With this advancement, scientists now have a clearer understanding of how massive structures, like black holes, interact. Project leaders say this advancement is only the beginning of work in this field.
I think this is a really cool example of how modern science is definitely all about collaboration and like large teams of people. And it's no longer, a lone scientist sort of working alone in a lab somewhere by themselves. Nowadays it takes a large group of people to get things done. And I'm just really appreciative to have been, a really small part of it in my own way.
Largent and Fia Morton were the two Bend-based OSU students who contributed to the project. From the Cosmos, Peyton Thomas for Central Oregon Daily News.